A newly discovered asteroid is racing towards Earth. This time, it's not Apophis, which kept us in suspense for years. The latest update from NASA reveals the truth about asteroid 2024 YR4. Discovered in 2024, this asteroid is the first in the history of modern astronomy to have had its impact probability revised upwards twice. This could mean that we will soon have to resort to an active asteroid defense measure for the first time. The current asteroid, 2024 YR4, is comparatively small with an estimated size of 50 to 100 meters. It remains in a range that does not pose a global threat. However, the size is sufficient to devastate an entire region and several thousand square kilometers of land. What is unusual about this asteroid is not its size, it's the probability of impact, which has now risen from 1.6% to 3.1%. For the first time in the history of asteroid observation, NASA has had to significantly revise the danger upwards. With the asteroid Apophis, discovered in 2004, it was the other way around. After an initial warning and an impact probability of 3%, the danger became less and less. In the end, NASA corrected the risk to almost zero. So, we survived Apophis. But now, 2024 YR4 is heating up tempers. The small asteroid could hit Earth as early as 2032, somewhere in the Pacific region, South Asia, the Atlantic, Africa, or Arabia. What would happen then? Will YR4 burn up in the atmosphere in 2024? Experts are unsure. Will the newly discovered asteroid really hit the Earth's surface in the event of an impact, or would it burn up in the atmosphere? Both are possible. YR4 is on the borderline in terms of size. It could detonate just before reaching the Earth's surface like the Chelyabinsk asteroid in 2013. That asteroid took the residents of the Russian city by surprise. All they heard was a deafening boom, and then the shock wave shattered the windows of numerous houses. Some people, curiously standing at their windows, suffered severe lacerations. The Chelyabinsk asteroid was probably a bit smaller than 2024 YR4. Nevertheless, the devastation it caused was remarkable. The detonation released the energy of 30 Hiroshima bombs in a matter of seconds, and this asteroid was comparatively tiny. If YR4 were to impact the Earth's surface, it would easily destroy an area of several thousand square kilometers. The immediate shock wave would be strong enough to wipe out entire neighborhoods, collapse buildings like houses of cards, and kill any unprotected people in the vicinity. In a metropolis like New York or Beijing, the explosion would not only cause massive destruction but also trigger fires that would spread even further due to the debris blown into the air. The detonation could cause an enormous heat wave that would incinerate everything in a wide radius. The shock wave would be so strong that it could damage windows and houses hundreds of kilometers away. If YR4 were to impact the ocean, the threat would be no less frightening. Such an impact would trigger a gigantic water displacement, which could lead to a tsunami of apocalyptic proportions. Depending on the asteroid's impact velocity and angle, the waves could reach heights of over 100 meters, far higher than the tsunami waves of the horror tsunami of Christmas 2004, which killed over 230,000 people. Coastal cities could be wiped off the map. Millions of people would have to be evacuated, and the water masses could penetrate deep inland, destroying vital infrastructure. But it's not just the direct destruction that's a problem. Such an impact could hurl so much dust and soot into the atmosphere that seasonal climate changes and crop failures would be likely. The exact consequences of an impact are difficult to predict, but one thing is certain: if YR4 were to hit land or water, the effects would be catastrophic and could endanger millions of lives. If it turns out that YR4 will hit Earth in 2032, we would certainly resort to asteroid defense for the first time. The deadline is December 22, 2032. A 3.1% impact probability on the Torino scale, that's a record. Despite the danger, experts warn against hasty panic. The record value of 3.1% on the Torino scale could also fall again. The Torino scale is a system for evaluating the danger posed by near-Earth asteroids and comets that could collide with Earth. It ranges from 0 to 10 and takes into account the probability of impact and the potential damage. Should the value continue to rise contrary to these forecasts, the international community would certainly make plans for an effective defense. Just letting YR4 crash into Earth would be pure madness, especially since we already have a functioning asteroid defense. In 2022, NASA proved with the DART mission that it is indeed capable of significantly pushing a small asteroid off its course. The probe's target was the just 160-meter large Dimorphos, and the impact of the probe was able to push it out of its original orbit by a full 32 minutes. In the case of an emergency, that would be enough to steer a projectile like 2024 YR4 onto a harmless path. That's encouraging for the future, and we will need it, because YR4 will certainly not be the last asteroid to pose a danger to us. The last major asteroid event was in 1908 when an asteroid of a similar size to YR4 exploded over Siberia. The asteroid entered Earth's atmosphere at an angle, slicing off thousands of square kilometers of forest in seconds and killing countless animals. Since the area is sparsely populated, it's likely that no people were harmed. Some residents in nearby villages merely heard a tremendous boom. That event happened more than 100 years ago. Statistically, a smaller asteroid enters the Earth's atmosphere every few years to decades. Most of the time, smaller rocks burn up without a trace. However, experts warn that a larger asteroid could come at any time, and it's not always certain that we will be able to see it years or decades before an impact. It depends on the asteroid. Very dark asteroids can escape our telescopes. This was frighteningly demonstrated by the approximately 1,000-meter large object Oumuamua, which almost passed Earth undetected a few years ago. Oumuamua was unusually dark and only caught the attention of astronomers when it was already passing Earth and heading towards the Sun. If this object had been heading for Earth, it would have appeared at very short notice. NASA needs several years to build a probe like DART, and we can't just send any old probe either. The impact force has to be precisely matched to the asteroid. Otherwise, it could be pushed too far or not enough. NASA also has to rule out the possibility that a deliberate collision with a probe could split or fragment the asteroid. If that were to happen, we would have to deal with several dangers at once. A fragmented asteroid could release several fragments into Earth's oceans, which could lead to an incredible mass tsunami if fragments hit the Earth.